In this spreadsheet, we're going to test the hypothesis that markets are efficient. First, we're going to look at the weak form of efficient market hypothesis, which says that past prices cannot be used to predict future prices. Here we have returns on Apple stock, monthly returns from 2017 going back to 2022. Here, March 2017 return was about 13%. So that's the return from the end of February to the end of March. And let's say we want to test some pretty simple and naive hypothesis is that this return could be predicted by a past return. So obviously we don't have in this data return from from February 2017. We only have a return that starts in March. So you could ask, well, is it return from in April predicted by the return from March? So let's create a new series in here that's basically going to shift this original series, and that series we could label as Apple, and it's the return from t-1, no, actually t-2 to t-1. And so in April, that would be the return from the end of February to the end of March, which is just this cell over here. So we can copy that all the way down. Control D, and we see that we shifted that Apple return 1 down, and so that we have in this column this month's return, and in the same row in this column last month's return. So we could run a regression and ask whether this month's return is predicted by last month's return. Let's run a regression. Perhaps we can use our data analysis add-in. I'll say okay to that. And I'm going to select the Y range. The Y range is the dependent variable. Actually, delete this. The Y range is this month's return. So, and arrow down, C6 to C36. The X range, the independent variable, is D6 to D63. Where are we going to put the output? Let's put the output somewhere. Oh, darn. I didn't mean to do that. Okay, let's put the output somewhere about here. I'll hit enter and I'll say okay. And here's the output. We can look at the slope coefficient. So it's a positive, but it has a very high standard error, low t-statistic, high p-value. So it is statistically insignificant, telling us that there is no statistically significant relationship between this month's return and last month's return. One thing that I'd like to do in this spreadsheet is show how we can estimate regression using a function, so that when our input values change, the coefficients change as well. Because the add in regression analysis here, this is hard-coded, right? This is a real number, and if I change the input here, this numbers are not going to change. We can do that using a linest, linear estimation function, and it's an array function, which means it returns an array of numbers rather than a single cell number. If you look up linest in online on Excel help, you can see that this is the output that it generates. M is the slope coefficient, SE is the standard error. If we have multiple independent variables, it returns slope coefficients for each of those independent variables, and the last one is the intercept. So let's apply that here. And I'm going to highlight just these 4 rows and start typing len est. And I have my dependent variable up here, comma, my independent variable is down here. And I'm going to say I want the b, just the intercept, to be calculated normally. I don't want it to be constrained to be 0. So I want my regression to have an intercept. I'm going to hit tab, and I want additional regression statistics, namely the standard error. So I'm going to hit enter on that, close the parentheses, and on PC to insert an array function, I need to hold Control and Shift and press enter, and it returns this array of numbers. On a Mac, according to documentation, you need a Control Enter. Students tell me that just hitting enter fills in all of the regressions output, so you may have to experiment with this. Clearly, it's going to be your choice how you estimate the regression, whether you use the len est or the add-in, but you definitely need to know how to estimate a regression in Excel. Okay, so here we have a beta is the same beta that we get using the old way, 0.9. Standard error is 0.13. If we didn't do it using the old way, we would probably want to calculate the t-statistic, which is just the ratio of the coefficient to standard error. You see that the t-statistic is very low. It's less than 1.96, so the coefficient is statistically insignificant, telling us that there's no statistically significant relationship between this month's returns and last month's returns. Let me just show very quickly if this were 10,000, 100,000%. Notice how the coefficients changed here, because they are function. They change based on the inputs changing. But here, the old way, the add-in way, it doesn't change. That's hard-coded, just estimates the regression and prints the output, but it's not flexible. So that's one case for learning how to use the len est function. Okay, so we didn't do this in class number 2, but I'm going to do it in this video. Used as a last 12 months return, excluding the most recent month, predict this month's return. So this is going to be a little tricky. This is maybe a little more sophisticated way of testing the weak efficient market hypothesis. And so of asking, hey, does last month return predict this month's return? Maybe we should be asking, does a last 12 months return predict this month's return? So let's see if we can calculate that here. So to calculate last 12 months return, we actually need to calculate the return from here all the way to here, from March to really February, skipping the last month. That would be from March to just January. That's just a technical convention. That's how certain definition of momentum use, not the full 12 months, but really return from 12 months to 1 month before the return that we're trying to predict. So let's we can actually label that. We can actually, to calculate return over 12 months, we would want to take 1 plus this return and take a product of that. So let's first do Apple from t minus 1 to t plus 1. And so that's just this plus 1. That's going to be helpful in calculating return over 12 months or 11 months, really. Control D. Because if if I now want to calculate the return from March to January, what I need is the product of these 1 plus returns minus 1. So let's actually do that here. Let's call that apple. And it's going to be return from t minus 13 to t minus 2. So we're really going to do this. We're going to calculate this for March. And it's going to be product of return from March to January. And that makes sense. So that's 11 months. And actually, I need to subtract 1 from it. And that's the return that took place from March to January, which is 12 months before March of 2018, skipping the most recent month, which is February. So I can copy that all the way down and Control D, and I can calculate another regression asking whether this different measure of past returns predicts this month's return. So let's do this again. Let's use the len-est function. I'm gonna hit enter len-est, and I will take my dependent is again going to be this month's return. I'm gonna hit enter, and the independent is going to be the last 12 months return. And here I'm going to say true, I want the intercept. I'm going to say true, I want those extra coefficients. Control Shift Enter. Now I've got a regression coefficients here. I'm going to calculate the t-stats of the beta coefficient, slope coefficient. It's actually negative. It's not statistically significant. So even if I use this different measure of past returns, I can't predict this month's return. So this would be a rejection of the efficient. No, this would be sort of we cannot reject the efficient market hypothesis because it's telling us that we can't use past prices to predict future prices. However, this is a pretty unsophisticated way of doing things. The way professionals are using the past prices is not just playing with just one stock, but they play with whole portfolios of stocks. And that's what we can do in our next tab. In this tab, I have data from Cliff Asness's website, or rather from his firm, which is AQR. And he published returns on portfolios that his firm constructed that are based on sorting stocks by momentum. So they take all the stocks in the stock market every month, and then they sort them by their past 12 months return. Again, skipping the most recent months for technical reasons. And so we have 5,000 stocks, and then they, at the top are stocks that had really high returns in the past 12 months. At the bottom are stocks that had really low returns in the last 12 months. So the top we have high momentum, at the bottom we have low momentum. Then they divide them into 3 buckets. The top bucket, that's MOM 3, momentum 3. That's the highest momentum stocks. There's a middle, and there's the bottom momentum stocks. The strategy that they propose is a long short strategy, which means that instead of investing $100, you actually start with $0 and you short certain stocks, meaning you sell stocks even if you don't have them. If you sell something, you collect money from selling it. You borrow it, you may have to pay interest on borrowing those stocks, but that's okay. You sell, you collect the proceeds from that sale of certain stocks, and you buy some stocks long. So it's called long short strategy. The resulting return of that portfolio is really the difference between the stocks that you are long minus the return on stocks that you are short. In our case, we're gonna long the high momentum stocks and short low momentum stocks. We're going to get a return that's equal to the difference between this and this. All right. So in this first month, what happened to the return on this strategy? It's a positive 3.9% return. Why? Because the stocks that we were long, they gained 4.7%. That's good. But the stocks that we were short, they also gained. They also gained 0.8%. Now, when we're short something and the price of the stuff that we owe to people goes up, then we lose money because we have to pay more to return it. After we borrowed it, we have to return it. So when its price goes up, we actually lose money. So the fact that those low momentum stocks actually gained in price ate into our return. Still, we made out a positive 3.9%. So we can certainly do this every single month. Every single month, we create these new portfolio. We sort the stocks by their momentum, buy the high momentum stocks, sell short momentum stocks, and do this over and over again. And let's see how that portfolio performs. So I'm gonna copy this down all the way. We've got like 50 years worth of data. Control D. We can certainly calculate rates of return on these different portfolios. So let's do that. Let's do average. And we'll take this and arrow up, down, close the parentheses, enter. That's fine. We're going to do stdev. Let's do the sample formula. We'll go and arrow up, down, enter. So that's the standard deviation. Sure, we can calculate Sharpe ratio on this. Sure. Yeah, I guess I need to subtract the risk-free. So if I assume risk-free is 0.01%, this is monthly. So no, just 0.2%. That's monthly over standard deviation. That gives me Sharpe ratio, pretty low Sharpe ratio there. Let me lock in the risk-free rate so that I can copy all of these formulas across. Control R. And I can see that the average return on those low momentum stocks is definitely half the return on the high momentum stocks, which tells you that, yes, the high momentum stocks do better. That if we go long high momentum stocks and short low momentum stocks, we're going to make money. We're actually going to make about 0.39% per month, which is a really nice. Oh dear, I was supposed to do this only for certain range, but let me just keep it doing it for the full range of data. I have one more column here, and in that column, I want to examine what's going to happen with my cumulative return on this strategy over this 50-year period. And I'm gonna see what my gain is. Let's say from investing $1 long and shorting $1. So that's I start with zero money. I short $1. I use that $1 of from shorting the stocks to buy $1 of long stocks. So my return, and I'm going to make this a cumulative return. So I'm going to say how much money I had the previous month, and to that I'm going to add how much money I made this month. So I'm going to make actually a negative of the return, or 1 plus the return on the stocks that I short. And I'm going to make a positive 1 plus the return on the stocks that I was long. So that first month, really the notional value of my bet is a $1 short, $1 long, I would have made 4 cents, which is 4%. If I copy this all the way down, I'm going to be accumulating that return. So I'm going to come down, oh, I showed many times, too many times. I'm going to go all the way down here, Control D, to see how much money will I have at the end. You could see I actually make money. I make $2.35 50 years later. Starting with zero, that's a pretty good return. That's really an infinite rate of return, because when you start with zero, when the denominator is zero, that's excellent. So clearly this suggests that momentum strategies generate returns and generate positive returns. Do they generate positive risk-adjusted returns? Well, let's estimate the alpha of this strategy. Now, if you recall how we estimate alpha, we regress the excess return on a particular portfolio on excess return on the market. Fortunately, I actually have a series here. That's the excess return on the market. This is the return on my portfolio. Because it's a zero cost portfolio, it's a long short portfolio, I don't need to subtract the risk-free rate, because there's no really opportunity cost here. Sometimes I'm taking $100 and putting it into this strategy. I'm taking $0 and implementing this strategy. So my dependent variable is going to be just a return on this long short strategy. I'm going to regress it on excess market return and calculate what is the beta and what is the alpha of this strategy. Let's do that. Let's do that down here. Let's use the linest function. I'm going to do enter. Linest. My dependent variable is my long short portfolio, and I'm going to regress it on excess market return. I'm going to include intercept. I'm going to include additional coefficients. I'm going to close parentheses, Control Shift Enter, and I should have my beta and my alpha. I'm going to calculate d-stat associated with each coefficient. And let's take a look what this is telling us. So our motivation was to calculate the alpha of this strategy. We see that the alpha is a positive really 0.43% per month, which is not bad. it is statistically significant. So it's not just a random occurrence that we got the positive alpha. This strategy actually generates positive and statistically significant alpha. So risk-adjusted return is positive. What really generates this positive alpha is in part the fact that this strategy is very uncorrelated with the market. You could see that the beta of the return on this long short portfolio is essentially zero, statistically speaking, it's zero. Why is that? Because we're really short half of the market and we are long half of the market. But we really don't care what happens to the market. Even if the market goes up or if the market tanks, we don't care because we're always, some of our stocks are going to gain value and some of our investments are going to lose value because we're long and short. So this strategy, long short strategy, is really market neutral, and that makes it a really low beta strategy. And in this case, it's not only low beta, it's also high alpha strategy. So this piece of evidence, in contrast to what we did with just one Apple stock, would suggest that we should reject the weak form of efficient market hypothesis, because we used past prices, we used a measure of momentum to create a portfolio that actually beats the market.